It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, everybody, and welcome to another episode of Pure Performance. My name is Brian Wilson, and to kind of go back to what some of the older kids out there might know, I'm going to pull a Casey Kasem and pull a long-distance dedication here because my colleague, Andy Grabner, is now long-distance. I believe this is the first podcast we're recording that now he is now back in Linz, Austria, back to his home. So, Andy, hello, and it's with a tear of distance that I welcome you back to the show. Hello.
Oh, thank you so much. Yeah, and I think we coined the term "I'm back in Mozart time," right?
Yes.
Mozart time zone.
Correct.
Exactly. It's a little challenging sometimes to figure out in which time zone we are putting. Well, we are organizing our recordings, and
right.
Now it's Mozart time and Denver time.
Well, and I was trying to look up something good for Denver time, and I looked up famous people from Denver. The first one I hit was Tim Allen, and I'm not really a fan of his, so I'm not going to go with him. And then I saw Lon Chaney, who played, I believe, the werewolf in the original movie, but I don't think many people are going to know if I say Lon Chaney time. They'd be like, what? That makes no sense. So we'll just keep it as Denver time.
Yeah, but talking about time, our guest today actually comes currently. You know, he's in a country that is known for being always on time. At least they have all the tools, and they create the most precise watches in the world from Switzerland.
Absolutely. Yes.
Yeah. And Acacio, I hope you're still with us. Again, instead of me introducing who you are, maybe you want to just share a couple of words about who you are, who you're working for right now, and just give us a little intro.
Hi, good morning or good afternoon, depending on the time zone you're in. My name is Acacio Cruz. I'm in Zurich, and I work for Google, especially in the frameworks organization. We do software frameworks for the rest of the organization, production platforms. I started my career a long time ago in 2007 at Google. I started in an organization called SRE, Site Reliability Engineering, and Gmail was my first project. So specifically on the delivery side of things, spam abuse in delivery. So our scope grew over time, and in 2009, I don't know if you want me to give an intro already about the talk, but in 2009 there were these very famous outages that the Gmail suffered. Mm-hmm. And out of that set of incidents, which were very, very public and very impactful to the product and to the organization, my team started a little project around load shedding, and that's part of the reason why I'm here today.
Yeah. So you mentioned a couple of things. First of all, Google. I guess most people have heard about this little company out of the Silicon Valley. Where you're one of the few companies where I believe the company name is implicitly used as a verb as well, right? I mean, you Google for something. I think you have a major impact on everyone around the world. And in case somebody kind of could escape who Google is, then please Google for Google.
And there's also the Google effect, the impact you've had on people's expectations on performance around the world, right?
Exactly. Yeah. Back in the days when we did a lot of work with people like Steve Souders around web performance optimization, Google was always the golden standard. And everybody was looking up to Google about how fast the page has to be. So very honored, Acacio, that you find the time and share your stories. Now, Acacio, I think the reason why we got to talk, we invited you, or the Dynatrace Linz team invited you a couple of weeks back to speak at DEF1 in Linz, and the talk that you gave was around load shedding. Now, I also had the pleasure to meet you twice now in person. First in March, I met you in the Google offices in Zurich. I happened to be in Zurich for a conference, and then you invited me over, and we got to chat. And I think you explained some of the concepts to me. And then 2 weeks ago, we met again at the DevOps Tallinn. You did a little different talk there around microservices. But I love the load shedding, and I think what I would kind of the first question that I have to you for people that may have never heard the term load shedding. Is there a quick introduction that you can give and kind of the problem that you wanted to solve with it? We understand that you had the big problem in 2009, as you said it. But load shedding, where does this name come from, and what's the principle of it?
Yeah, so succinctly, load shedding is it comes basically from the metaphor of water, like when you shed water or you shed something heavy off your back, and basically is avoiding a workload to become overloaded by avoiding work, right? Essentially, like at the core of the principle is don't do work that might damage your task, your process, your mission, your goal.
So my goal of trying to hang out, I can say I'm load shedding, boss. Sorry, ignore my stupid interjections. Keep going.
You're load shedding work. That's exactly the nature of that. The core principle is while still being productive, and that's what some people are not able to.
Right.
I think the core principle then is actually knowing what is the maximum amount of load I can handle before I get overloaded. Right? Isn't that the biggest challenge then?
Yeah, correct. So even though the principle, like the goal is fairly simple to articulate, is actually fairly complex, because knowing what is the actual load in a task is not a simple process, and it's actually not unidimension at all, right? It's not just about CPU; it's about memory, it's about I/O, it's about latency. So over the years, the bulk of the work that my team is doing is actually around the modeling of load, because effectively there's two parts to the problem. One of them is reject work, effectively, but the second part is actually the most important one, is actually knowing when to reject work, which means that you need to know exactly what is the load of your task, your process, and that's where it becomes really complicated.
Mm-hmm. And so knowing, this is, are these, typically when we talk about load, right, I would assume that the key metric or the most basic metric would be, the number of requests that you can handle. But I would then assume that you have a uniform distribution of the same requests coming in all the time. And I know in your talk at Dev1, one of the principles that you brought up is actually categorizing the requests into different buckets, because not every request is the same, right?
Exactly. So that was one of the early lessons that we had, especially the service that caused a lot of the Gmail outages, is that a request per se is not enough information. And a lot of the systems out there are based on max requests in flight or, number of requests per second, rate limiting. But for most systems, requests are like quantums. There are big quantums, small quantums, and you don't know until you actually measure them. So there are multiple techniques. You can use bucketing, as you mentioned. If you already know the characteristics of your requests, well, you can try to bucket them. This is a fairly coarse process. But over the years, we actually lean towards different methodologies as well. And for instance, one of them, but that is afforded to us because we have full introspection into our stack, and my team also does the framework side. We actually measure real time the cost of every request in flight, and that enables us to actually compute the cost request and actually have a trend per client. Because, for instance, one of the things that puzzled us, for a long time, the system I'm referring to was actually the context, managing the contact list of a user. And our top customer was Gmail. And one of the things that puzzled us was that Gmail would send traffic to the context from different clusters, from different sources. And even though it's the same, customer, which was email, using the same request type, some clusters would be cheaper than other clusters. And it took us actually many weeks to figure that out. And we only figured out in the end because I was a Gmail SRE in the past, and then I recognized the cluster names. So I recognized that the clusters that were younger had the cheaper traffic. And then we had the realization that because the clusters were younger, that's where new accounts were being created. New accounts tend to have less contacts. Therefore, the average contact size per user on the new clusters was smaller than the average contact user on an older cluster, and therefore the same traffic was least expensive in them. But all of this came as a non-obvious consequence of the simple process of provisioning for Gmail. So this is one of the reasons that over time we moved away from requests as a pure metric and also manual bucketing or even mathematical modeling. And we prefer now to use real-time live metrics and do cost accounting per request. Does that answer your question? Probably too much detail.
Well, I wanted to bring in you in your talk. You gave a good example, just to bring it down to maybe some of the people who might not be grasping it 100% yet. I think you had a great example in your talk about if you did a query for, and I'll put myself in your place this time. This way, I'm not making fun of you. If I did a query for all of my friends, I'd come back with maybe a query that would take 2 milliseconds because there'd be 5 responses, right? And if I did a query of all of, I believe you used Britney Spears, right, in the thing, which exactly. A little bit of a dated one, but yes, if we did one for Britney Spears, you would get hundreds of millions of of rows of a payload back, which is where the idea of a requests are not equal, and it's about the cost of the request. And one thing I wanted to abstract from that was also, the first thought in my mind was, well, instead of, let's say this is going back to a database, you throw in a caching layer, right? Because that's always a great performance tip to put in there. But I think even if you throw in a caching layer, you still have to pull in that payload from cache. It might not take as long as running the query. And if you're trying to get to those Google fast speeds, right, that's when you really have to start thinking about, okay, yeah, we do have a caching layer, which is a huge improvement over hitting the database directly, but there's still a request is still not a request. There's a payload that has to get transferred.
Exactly right. A few bytes versus a few megabytes. I can actually, share that when we went and did this implementation for the first time, one of the things that we found very direct correlation between a request cost and the dependencies. What happened in the background was actually bytes read. So if you read X bytes from a backend, it could be already in memory, so it could be from a cache, except or reading X memory megabytes from the same backend, it correlated linearly. There was. Because most of the data, most of the services in the backend are simple. What they do is they read data, they transform it a little bit, and send it back to the client. So there's always some measure of data size. That's one of the most important components in request cost.
Right.
Mm-hmm. So I want to quickly rewind a little bit for people that may have not even started bucketizing the requests. So you mentioned there's different approaches of doing it. And one way I could think about it is if I have, let's say, a classical application where it's monolith already broken into smaller pieces, I could look at production data and I could start bucketizing my requests maybe by looking at the different URLs and the URL and parameter combinations. And then is that a good approach where you can say, well, let's figure out what are your small, medium, and large hitting transactions by looking at a combination of URL and parameters, and with that you have at least an estimate? Or is this the wrong way? Would it be more like bucketizing the critical ones, like what are important requests to the business or to the feature versus less critical ones?
So those are two different dimensions, So criticality, as you mentioned, should be used on the moment of decision of what to drop. So that's one dimension. We actually have, it's just an approach, but that what we use is basically we use critical, sheddable, which is slightly less important, async, and here things like a refresh of contacts in the background, and finally batch. Batch being stuff that generated from MapReduces or pipelines or even server side, but batch work that can happen somewhere else, right? This is just one possible classification. You can have more levels or less levels depending on what's relevant to your organization. But then that is used for the moment of, I've already come to the conclusion that I have to drop something. I have 3 requests. Which ones will I drop? Right? And you start by the lowest priority. The cost accounting is a different dimension, because you can have the same request being critical, and you can have the same request type being batch, depending on the source. Typical example is update my contact now because the user is waiting because he just clicked OK on changing email address, or you can have a MapReduce pipeline that is running that is just moving everyone from @live.com to @hotmail.com, going back into the past, for example, right? So even though the request is the same, and the cost will be the same, the priorities are different. So that's one of the reasons why we keep cost accounting separate from criticality. Typically in our stack, the request comes with the criticality attached. If any doesn't, there's a default criticality. But going back to the question about bucketing, if I may ask, it's a potential way. What we found that it's very ops heavy, because as releases change, so we're talking. What you're talking about, we call query cost modeling, and query cost modeling can be done in 2 ways: either top down, where you say I have a model that I create, and then I do the topology and taxonomy of all the requests, and I assign a cost, right? Or it can be done, which was our first approach, which was done statistically. You run against the system, you check the logs, and then you compute the model. If you have a good person that is able to do linear regression, for instance, and stuff like that, you can actually get those inferences. And for instance, that's what we did for a long time on the situation that I mentioned before, about that we came to the conclusion that bytes read was the most important criteria. But unfortunately, as your software evolves, as you build features, that changes quite quickly. An example is read all my contacts. That has a certain cost, but over time, for UI prettification reasons, somebody decides that read all my contacts should return the same data but sorted. So that same feature, that same request becomes more expensive silently. And that means that the model is, if it's manually done, it will be completely out of date. If it's done from performance data, will be out of date by the refresh period of analyzing the data. And meanwhile, you have a huge gap between your cost prediction and reality, which can be, in certain cases, can be an outage.
Yeah, pretty cool. And thanks for your insights. I just thought, maybe bring an idea up for people that have not done anything. So that would be a good way to at least get started. I remember, I think it must have been at least 5 or 6 years, I wrote a blog on the resource budget of a request, but I had a request a little more broader. Back in the days, I did a lot of performance optimization. So we talked about measuring the resource consumption of, let's say, loading a page from browser all the way into the database. And basically, this is kind of what you are doing now, but on the fly, right? Back in the days, exactly. I did it in the testing environment. I used testing tools to drive a certain feature on a build-to-build basis, and then using whatever the browser gave me and also the backend monitoring tools to figure out how many bytes are sent over the wire from the browser to the web server, what happens between the web server and the app server, and then the app server to the database. And then we basically used that resource consumption, or we then also framed it into, you have a certain budget, and you want to, when you're making changes through your code, or to your code, you want to stay within a certain budget limit.
Correct.
And,
so just to I wasn't put down your idea actually, Andy, because in some places it actually makes a lot of sense. And if you measure the requests data, you can actually build a predictive model. Our case in our service was particularly complex because we had a lot of data and a lot of customers. But if you have something where it's not dependent on the data itself, it's more driven by the URL or by the request parameters, then you can actually have this simple model of keeping the logs measured, and then from the log mods, extract the correlations and create basically your cost model. That if you do it like daily, your model will be off at most by one release day, right?
Yeah.
So that is something that is possible. You just need to accept that is over time is going to have a management cost.
Mm-hmm. Yeah, but I still, I obviously where we should, help people to get towards is what you're doing. It's dynamic cost measurement. And how do you call it? I think you have a metric for that, right?
Yeah, there's several internal names. I think one of the areas where we also are not necessarily on measuring the cost, but looking at the secondary effects. And there are some very interesting approaches that are even available outside of our, rich instrumentation environment at Google. For instance, one typical method that is available, and it's actually very interesting in event-oriented programming models like Node.js and similar, is basically looking at the event loop latency, right? So what there's even some implementations out there. What they do is they actually drop these probes on the event loop and then measure how long it takes until they're called again, right? So if the event loop becomes, past a threshold, it basically flips the state of the machine, so it will reject new requests. I think that's a very interesting model because it also accounts for factors outside of the direct processing of the process, right? So that's one of the things that, for instance, we learned was what we call antagonistic workloads. Because for those that are not familiar at Google, we run things, in a containerized environment that's now being popular, but we've been running this for many years now, and we're not in full control of what runs in the machine where we run a job. So you might be running a user-facing workload, and then the cluster manager schedules, for instance, a MapReduce or pipeline, and that. Even though we actually have container isolation, but at the bottom end is the CPU, memory lanes and bandwidth, and those become constrained, which means that the performance characteristics of your job change. It can be pretty dramatic in some architectures. And therefore, performance of a job can actually change anytime. That's one of the lessons of our world is that you cannot count, even if you do a fully fixed modeling, world is changing around the process, even down to the physical machine. So using other metrics like the latency of an event loop, or using thread load latency as well, or thread count, similar almost to the Linux uptime data, where you actually see the number of runnable threads and what is the state of your thread pool, for instance. Those are interesting secondary metrics that almost everyone can implement.
Andy, that's funny. Some of that reminds me of way back Acacio. One of the things we used to promote a lot was the idea of when looking at your database pools, don't look at the pool usage, but look at instead the amount of time it takes to execute get connection. Because if your pool's 100%, but your connections are still really, really fast, who cares, right? Whereas if it's starting to creep up, and that's like just taking back many years ago, expanding that into this idea where you're doing it on a much grander scale. I think it's really cool. It also just kind of goes back. I remember when I heard that idea, I said, that makes a lot of sense. And it's kind of cool seeing that, I guess it did make sense, because obviously you guys are doing a much more complex and mature model of something like that.
Yep. Yeah, so
And
that's part of the. Oh, apologies, memory laden.
no,
Go ahead, Andy.
no, I was just wondering. So if you look at these metrics and you know that obviously it's time to kind of stop accepting new requests, is this the only thing you do with these metrics, or does this information then also feed into your scalable architecture where you say, well, this particular container may have start to reject requests, but then we have to spin up more instances. So I assume you also use the same data points to scale up your infrastructure.
So we actually have separate control systems because load shedding, let's say, horizon of information is sub 10 seconds. That's you need to be able to rely to react to load very fast. So part of the problems that we face at our scale, but I think other people have the same concerns, is that load can spike very fast. And we're talking about, within 1 second, you need to be able to effect load, otherwise your task is going to crash. What you're talking about, which is basically scaling a job, to accept a variable workload, those control systems exist, but they operate at a wider time frame, right? We have some systems internally that actually are able to spin load, and Google Cloud is actually bringing systems in that space to our customers, but they operate as well in the, say, 1 minute. But if you have a spike in traffic for whatever reason, and most of the times those reasons are actually bugs, on the client side, it's unintentional. You need to be able to survive until those systems kick in, and this is where load shedding fills the sort of the availability gap.
Yeah. No, that makes a lot of sense. And I know you had another train of thought earlier when I interrupted you. I'm not sure if that's still there. If it's still there, feel free to continue.
I was just going to say that there is not a binary accept reject, right? So part of the way that we can use this information, basically, there's multiple metrics to measure the load. And for instance, one of the interesting ones that come to us often in the world of streaming is actually memory pressure. Because if you're doing video streaming, it's almost irrelevant what is your CPU load if you don't have memory to read the data and ship it out. So for the streaming environments, memory pressure is the key criteria. In some areas where is around IOPS, right? Because the disk is a fixed capacity. So regardless of the CPU or memory, IOPS are important to measure and to understand and to model. But one of the things that we've learned as well is over time, using a single metric is usually not the best approach. So we sort of have all of these cost trackers running, and then the prediction of the load is a combination of these cost trackers, and we can plug in more cost trackers for specific applications, and we have a default formula that sort of measures all of these and then makes a verdict that is a combination of all of these input factors.
Mm-hmm. Honestly, the more I listen to this, the more I think I have to start writing another series of blogs on how we can use, now just a little connection over to Dynatrace, how we can encourage our customers to use the Dynatrace API to automatically pull out these cost metrics, because we have the end-to-end tracing, and we do the instrumentation for our customers, and then we also have APIs where we can actually pull out things like what's the resource consumption, how many bytes do we read from the backend, and we can do this per request because we have these pure paths.
Correct.
So
that would be an excellent way if you can, from a product, if you can automatically generate, request cost prediction or request cost estimates per target, and parameter. So you have a combinatorial explosion, all of this, so you kind of need to manage this to become, to become still useful. But that would be a very interesting product, because then you can actually then tie into the mechanism that the users, the customers can use to throttle traffic.
Yeah, exactly. And then, I mean, we already, do this multidimensional baselining based on metrics that we are all aware of: response time, throughput, number of database queries. But then, as you said, if we would allow our users to define like this formula where they know best what to factor in, and then additionally store this information on a request per request basis, and then do the multidimensional baselining on that, and then make this data available, then that's awesome. Yeah. Now, Acacio, so you mentioned in the very beginning SRE, so site reliability engineering. I would assume, if our listeners out there, if they think about, wow, this is all cool, I mean, it sounds amazing, we have to do it, but who is doing it? I would assume that this is the new role, or this is one of the roles of the site reliability engineer, figuring out how to get this data out, but also how to then help the architects and the engineers to actually build applications that allow this type of measurement, and then also allow dealing with heavier overloaded, and then correctly handling that situation. So do you agree with me? Is this one of the roles of site reliability engineering?
Yeah, so when we started this work, we actually were SREs. My whole organization, we did the first 5 years of the load shedding team was an SRE team, and that work was that experience and that knowledge. Sometimes, painful as the Gmail outage case was, it actually taught us a lot. And a lot of the techniques that I mentioned, a lot of the insights that we learn over time were actually after postmortems, right? For instance, we learn after an outage that a feature can change the model, the model cost of a single request type, right? So we learn that CPU tracking is not necessarily complete to have a load view, right? We learn after another outage that with a different service that memory tracking is more important for different workloads, right? So all of this comes as part of the role of SRE. Where we've gone past, over the recent years is because even in SRE, there's a lot of scope, there's a lot of knowledge. So my team is doing this for 8 years now. There's a lot of knowledge that we basically packed into code and into configuration and into best practices. So we're trying to make as zero conf, as we call it, as possible. So nowadays at Google, SREs are trained with load shedding, how to operate our systems or to tweak it for better optimization. But a system can be built from scratch with zero conf and have a decent load shedding configuration that will work for the majority of the cases. And then, of course, different workloads, different work types, and you can actually always squeeze a little bit more, right? Because, as I mentioned before, the goal of this is to make the verdict of should I accept traffic or not. And we have some policies, but in environments where high performance is needed, very high performance is needed, or on the contrary, where like resource usage accuracy is needed, you actually need an SRE that understands that specific workload, that understands the constraints of the system to go and tune our default parameters to figure out exactly when should we start doing load shedding, when we should actually be a little bit more flexible in the load, when we should actually run tighter and hotter, even though at the cost of latency. All of those are decisions that the system and the architecture implements, and our frameworks allow to orchestrate. But we need somebody that has that really deep knowledge of the system to be able to effect.
Mm-hmm.
Hey, Andy, I just wanted to bring up that we've been talking a lot about the different signposts and some techniques of measuring and knowing when to load shed, but I don't really think we dove too much into approaches to load shedding. And I'm referring specifically to, if we look at the presentation where Acacio's looking at traffic and breaking requests down into the ideas of batch, async, sheddable, and critical. right? Which is what you do. And if I understand this whole concept properly, is when you see these different things, like if your node loop is slowing down, if certain other things are having an artifact, we talk about shedding, but what do we shed? Right. And that's the idea of, okay, first thing you could do is probably, and I'll try my hand at speaking this, drop your batch calls, just drop those completely, stop all your asyncs, and you'll go ahead and do retries on these later. And then you have traffic that you categorize into sheddable, which you can start chipping away at as well. And
correct.
But making way for the critical ones that absolutely have to run now, can't be rerun later. But that's what the end goal is with all this data that we're collecting, right? Is to be able to find a way to reduce the load on those servers by basically stripping off or shedding the unnecessary pieces currently. And part of that is by identifying and categorizing the different type of traffic. Or Andy, is that what you were talking about when you were talking about buckets before? Or
yeah,
is this
exactly. Yeah.
Okay.
Yeah.
All right. So maybe you did cover it just when you were talking buckets. I was thinking a different way.
But that's perfect. I mean, that's also where as Acacio also corrected me earlier, it's like two concepts, right? The first concept is knowing when we are getting to a stage where we are overloaded and we have to shed load. And then the second thing is knowing what to shed away. And I think that's the key thing here.
Yeah. And I do encourage everybody to, we'll put the link up to the talk. It's I don't want to say it's too technical. It's very technical for, again, I'm the dummy in the group. So at some points I was like scratching my head a little bit, but overall I got a ton out of it. So it's still very, very, very worthwhile watching. No matter what level you're at, you're going to get a ton out of it. And it makes a lot of sense. And just, I think the graphics really speak really well to these concepts. So I think it was a really well done presentation for people of all levels.
Oh, thank you. I always told that I need to simplify it, but the problem that we have is if we talk to a high level, it's not useful.
Right.
But to get it to a point where it's useful, you need to take it to a level of complexity. Right. That I know is hard to grasp, but we try the best.
I just took it as some of these things are some things for me to research and learn. If it went a little over my head, so I didn't take it in a negative way. But I think there's a ton in there that's very accessible. So I think you really kind of bridge the gap. And if you have somebody who takes the approach I do, they'll say, well, let me go look into what those things mean. So anyhow, I didn't mean to sidetrack there, but I just wanted to make sure we kind of covered that point a little.
Yeah. So Acacio, I have two questions on the thing you said last. First, I wanted to go into quickly SRE again when you started, because I believe a lot of the people that we are talking to right now, they're understanding what SRE means and the new role. But how do you get started? And more importantly for me is, which roles did the people have within your team when you started it that moved over to SRE? Was it more driven by folks that had operational experience? Was it more folks that had a load testing and a performance engineering background? Was it architects? Because I think a lot of people wonder, is it the right thing for me to move towards an SRE role? Do I have to be the one that needs to figure all this stuff out that you tell me, or not?
So in terms of role in SRE, we don't have that sort of partitioning. My teams were comprised of both people with what we call SysEng background and software engineering. And the software engineers would meet the bar of any software engineer at Google. And the SysEng, we actually had a little bit more systems knowledge, kernel knowledge, networking knowledge. So that's how we differentiated. But that said, basically, at interview time, when we got to the job, there was very few differences. And we also don't have really the architect role. It's a little bit lofty. I think it boils down to interest and aptitude, right? So for some people, the area of traffic management, because this is where it really falls, it's very interesting. Because we've been always talking about load shedding on a process, but this is actually just let's call it the leaf of traffic management. Traffic management is the process where you have a flow of requests that is coming, and it needs to find a target, somewhere to reply to that request. And there's the routing aspect. Shall I go to cluster A or cluster B? Should I go to the America zone or to the European zone if you're running on a Google Cloud or Amazon or something like that, right? So that's that part. The second part is actually then to figure out what is the most appropriate for the request, and then finally the request comes to the last stop, which is the process that then handles it, and it can either be very quick saying no, I can't handle, or can do the proper work. We've been focusing on the last aspect, but at Google we tend to treat all of these things together, right? So the SRE organization is very focused on capacity planning, and capacity planning is capacity to handle the requests, and then therefore the traffic management is tied also to capacity planning, and all of these process, even from a deployment of the architecture of a system. There's always two questions that are asked: is where is my client traffic coming from, and where are my backends? So, and that actually is part of the whole story of the role of managing traffic, and then managing load shedding, and managing capacity planning, and managing the routing of traffic. Mm-hmm. So people that like that sort of thing are the more appropriate for this role, basically.
Cool. Yeah. Well, that was a nice summary. That was a nice overview. Thank you. Hey, and the other thing that I wanted to cover, that I wanted to touch on, and I know we talked about this in Tallinn a couple of weeks ago, and I really, every time when I talk with you and we share some thoughts, it always feels that I always learn from you and go away with some new ideas, but I always feel like I never give enough back to you. So hopefully at some point in time, I can also, give something back to you. But what you inspired me again in two weeks ago, and you mentioned this earlier, you said zero configuration. In Tallinn, we talked about, or you explained what an engineer has to do at Google to start a new microservice. I think the minimum configuration is just saying, what is this microservice all about? What type of service is it? Is it the front end and the back end? Who is the owner? And that's pretty much it. And based on this individual pieces of information, you can actually automate the generation of all the other configuration elements that are necessary in the end-to-end delivery pipeline. And then you looked at my monitoring as code configuration, and you said, well, it's a nice thing what you do, but it's too much configuration still. There's so much that can be automated, and I really like that because you're right. There's still too much configuration. I think I read a statistic, and I think it was some CTO from some large system integrator, and they said that they are currently fighting with the big challenge of having a ratio from 1 to 4 from code to configuration. They came up with so many configuration files. Nobody has any clue anymore what this is all about, and it's all getting too complex. And basically with your approach, boil it down to the bare minimum and then just automate the generation of everything else that needs to be generated for all these other tools, I think is a great concept and a great best practice. So
yes, thank you for touching that as well, because it's not just that we can generate configuration. There are several principles that I specifically my org believes in, which is the configuration needs to be machine editable, so that you basically can also read even user generated configs, can read it, process it, and regenerate back if need to. Because there's one aspect in today's systems which is still not common, which what I call managed configs. For the most part, in most systems, people create a config. They probably have a nice template with most of the best practices, and then they clone it and then they tweak it for their specific instance. But over time, the best practices change. So there is a certain bit rot. So what was golden today is going to be slightly stale in 6 months, and it's going to be completely obsolete in 3 years, and in 4 years is going to be, a pile of junk, right? So we need to move from a world where we clone templates and we keep reapplying settings to more of an approach where when I say manage config, you actually have, let's say, let's call it a template config, and then the user of that system injects the changes that it needs for its system. So to remove from the abstract, imagine that you have a let's call it Apache config. And Apache is fairly complex as well once you start getting to a bunch of backends. But instead of having an Apache config template that people change as they add new complexity to their site, what probably they could do is to have a tool that reads the Apache config and then injects a specific site config done in a configuration language, maybe a text protocol buffer, or JSON if that's how the tool can operate. But this means that every time that you change the Apache config, you can again regenerate the final config without actually having to change the config provided for that instance. So you keep it alive, you keep it fresh, and that way you can integrate the different types of configs. For instance, you have CGI. You can actually define how a CGI is modeled, and then how that gets merged into the Apache config. But also enables more interesting changes. This is where we are at the current stage, which is, imagine that you come to the decision that you no longer need Apache, or Apache doesn't feel your needs, and you need to go to Nginx, or light HTTPD, or HA proxy, or the new thing that Facebook just open sourced. You can actually then transparently bring that site definition that you created, and then now generate an Nginx config, without having to change everything on your pipeline. You just have one person or a subset of the people that really know the config environment, and then can keep it alive and fresh.
Yeah, well, that makes a lot of sense. No, and it was very inspiring. I mean, and I think your talk from Tallinn is also online. At least the slides, they will be published in a way. Well, I'm not 100% sure, but I think
I'm not allowed to publish slides. So
okay.
It can be, but if it was filmed.
Yeah. But I think at least now we have the short podcast that we recorded. And I'm sure there will be some opportunities. So anyway, my shout out again is, if anybody from the listeners wants to check out the other things you have to say besides what you have said at Dev1, I'm sure there's other opportunities to meet you in different conferences, or just, I think you also, partly you contributed to books, right? You were contributing to the SRE book that came out a couple of years ago.
Correct. So my TL actually, for the load chatting team, Alejandro, he actually is one of the authors of the traffic management chapter, and where he also outlines the load chatting principles there. And then there is the broader topic about frameworks as part of the way to do zero conf and best practice in the services, from the ground up, right? How to build systems with best practices, which I co-wrote that with one of my TLs on the systems platform.
Mm-hmm. Pretty cool. Hey, Brian, do you have anything that you wanna still cover for especially knowing our audience? Is there anything open, or just point them to more resources and we put the links up?
I think we put the links up. There's quite a lot. They're very rich in information. I think one of the things I get out of it the most, which is a challenge for anybody, is to challenge your assumptions. One thing Acacio talks about is, with the idea of retries, and a lot of people hate the idea of retries, and how if you do them right, they can actually be faster, and just even the idea of tossing away this traffic and doing it later and figuring that out. Most people just kind of would be like, how can you do that? But it's like, no, it can be done. And I think a lot of these, the Dev1 presentation goes into that. quite well. So I think that's going to cover that well. There's a lot. I think a lot of the topic in here, we can talk about a lot of it, but I think a lot of it's also served to have the visuals. So from my point of view, I think we covered what's mostly coverable without visuals.
I'm glad you mentioned retries. If I can probe in that topic, as you said, there's a cultural resistance even from the Google developers, because they have the good intention, right? It's like, I don't want to return an error to my customer, to my client. So I'll do my best to handle just this one request, right? That is actually the attitude, and it's positive. But the reality is, if you do this statistically, you end up with high latency, and high latency is the death of a product. So being able to say, I will embrace, throttling, because what I'll do is I'll really try my best to make sure that the majority of my requests are fast. And if I can't do it fast, I'll just reject it. So if you embrace that approach, and then you say, on my client side, I'll work with my clients so that they also, embrace this process. And if they see a throttling error, they immediately retry fast somewhere else. If those two things combined are very powerful. Just to go back to the original system that I was mentioning before, the contacts, we used to have quite a bit of tail latency. This is what I call, like, on the 99th percentile of latency was quite high, because part of it was very large contact lists. But I mentioned before, for instance, we would have antagonistic workloads. For some reason, sometimes some of the processes get what we call sick. Either there's a MapReduce running on the machine, either there's a problem with memory contention, or there is like very strong work being done because of garbage collection on a Java task. For whatever reason, sometimes some tasks get sick. So what you want very quickly is to identify that, and basically, it's almost like if you have a rock in the middle of your stream, and the stream is your request. You want the water to flow to other areas, and if you very quickly get the signal that task is overloaded and getting throttling, and you divert your request elsewhere, overall and statistically, your system performs much better, much faster, even though there is a retry.
Mm-hmm. And I think on a very different and much more gross level, another concept that ties into that, but again, being very different, but also kind of counterintuitive to what people might think in terms of retries is, and Andy, I don't remember if this was in one of the cafes you recorded or if I read this somewhere recently. I don't remember where the concept was, but for overall sites, right? When sites are having an issue, the idea is you're much better off telling your customer, come back later, we're having some problems, then try to serve them super slow, because if they're trying to use the site and it's crawling slow, they're going to hate it and they're going to have a negative opinion of you. Whereas if you just say, hey, we're having issues, can you try back in 10 minutes or whatever? The majority of the people will be like, oh, great, yeah, I can do this in 10 minutes.
Correct.
Of course, you might lose a few people, but just this idea of sometimes taking a hit is better than trying to persist.
Exactly. I used to have someone in my team that before they used to work at Ticketmaster, and Ticketmaster is a very interesting human load events. Every time they have a popular artist that starts selling tickets, millions of people try to get the tickets within minutes. And they do exactly that. They do load shedding on the application side at the human scale, right? Which is basically, they know that they can't handle 1 million people clicking on tickets, and the system will crash down. So what they do, they apply load shedding very simply as the number of people that are allowed to go from I'm seeing the Ticketmaster front page to I'm allowed to actually enter the sales pipeline is limited. So they rate limit there, the transition, and that is a much better experience than clicking on the buy button and wait for 15 minutes and get a timeout request, right? So that usability impact, it's much more positive for them to lose the customer that will go away because you can buy the ticket because it's at the gate, than actually lose the customer halfway through the process.
Yeah, although
your point is very.
Although you always know it's some bot somewhere who got in front of you in line.
But latency is the death of products.
Yeah.
I think the credit to this what you mentioned earlier, Brian, was Ryan Townsend from Shift Commerce. He was also one of the speakers at DevOps Tallinn. He talked about this, better an experience than a slow experience. Yeah, I think that's the thing he said. No, that was cool. All right, Acacio, did we miss anything? Is there anything else you want to make sure that people understand? I mean, again, knowing that they will be able to watch your full presentation from Dev1 and follow you on all the other work, but anything else where you say, hey, this is something people should understand about load shedding, especially when they get started? Anything we missed?
Yes, I think there's only one very high-level principle, because hearing a talk, and as Andy has said as well, it's a fairly technical area, but then people might walk away with the impression this only applies to Google. But the reality is, Google, at our scale, sometimes we can handle events that are outage potential. With our resources, we are fortunate that we are resources that can solve problems. But if you're a small company and you have, your business that depends on one app and you have, 6 servers that are running, those are critical to the business. So it's even more important for a small company, to be able to survive an event. And in the current, compute world, distributed world, is a very hostile world, right? A script kiddie can, DOS almost anybody and take you out of business. So being able to survive, hostile players, being able to survive client-side bugs, being able to survive unexpected events, being able to survive fat fingering is even more critical at a small scale, because that means that you're surviving not just the application, but you're making your business survive. So even if you don't go, full, techno into load shedding specifically, but starting considering, how critical systems are to the survivability of the business, and then applying some of these measures and inching your way towards basically surviving. Survival is the key.
Awesome. Hey, Andy.
Yeah. Do you think it's time?
I think it's time to summon the summarator.
And summon the summarator, yeah.
Let's do it.
I think what I learned today is that the concept of site reliability engineering that has been floating out there for a while, but I know that while Google has been living this and further expanding it and refining it over the years, many of the people that we talk to are just getting started and they want to know what this all means. I think what I learned today, it is one of the aspects of site reliability engineering is trying to figure out how to help the company and the business to build resilient systems. I think resiliency is in the end what we all want, whether it is making sure a spike in load cannot bring the system down, whether, as you said, a script kiddie cannot bring the business down. Thinking about these concepts on how we can shed load off the critical backend processes, then obviously making sure that the architecture that has been used to build the systems can handle the situation of, now we know we're getting in an unhealthy state. How can we shed load off? How can we correctly respond errors to the next level? How can we respond the error state back to the customer in a way that we're not, making them angry, but making them want to wait. I think these are all extremely interesting concepts, and I believe it's going to be part of many organizations that are now just thinking about what site reliability engineering is for them. I really much encourage everyone to watch your presentation, to read your blogs and your books, and simply just be open that these are the things we have to do these days to make sure that our digital businesses become successful and stay successful. Because if you help somebody to become successful and you don't look at these concepts, then a tweet of somebody famous or a blog post, a news article may shatter everything into pieces if you didn't do your homework well. And I like your last kind of recommendation in the end, where you said, you may not do everything at once, but start thinking about how you can at least, build something that is resilient against a script kiddie or something like that. I like that.
Thank you. Oh, you choked me up there, Andy. And I just want to add a couple of my thoughts to that as well. First of all, I just want to, thank you for being on the show. I think it's, wonderful that companies like Google that have resources to actually put time, people, and money into solving these problems and looking at these problems, turn around and then share it with the rest of us who don't necessarily have the ability to set up these projects around it. Obviously, it's critical to performance, but a lot of times, especially in smaller companies, it's just plow ahead. So the fact that all these companies are sharing this information is wonderful. So thank you for being part of that. And Andy, a lot of times, as you know, some of the topics are a little bit more over my head. Acacio, my background, very briefly, I was a communication major who ended up somehow in load testing because I was making a crummy salary and I had a friend working in computers making twice the amount of money that I did. So having an inquisitive mind and an analytical mind, I eventually got into load testing. So some of the deeper topics, go over my head a little bit. I'm always trying to level up, but I think what I enjoyed about this one a lot is it's so performance filled that the more I look at it, the more I listen, the more I see, the more I can find and hear a lot of fascinating ideas to dig deeper and deeper into. I really love the idea that not all requests are equal. That's kind of a thing that used to come up a lot, just even in load testing, right? You wouldn't run certain requests a lot because they're so heavy, but then there was always the question of, well, what if users do it, and you'd have a developer saying, well, that's not how it's meant to be used. I'm like, well, what if they do it, right? If people keep searching for Britney Spears, because she suddenly went to rehab again or something, things like that will happen. But I also really loved the idea of other indicators that systems are going down, the node loop you talked about specifically, and ideas where, there's something running in a process or in a service that might indicate that there's a larger problem going on overall that you can't see quite as well. And maybe certain other kind of traditional metrics wouldn't quite be an indicator. But the idea of suddenly that loop that goes through is taking longer. Well, that's an indication of an overall larger issue. Just a really fresh way of looking at things and opens a whole, kind of can of worms, but in a good way, of new ways to look at performance. So again, thanks for sharing it. I think there's a lot to dig into this, and a lot to get out with repeat viewings and listens.
Thank you for inviting me. It was a pleasure, and I'll just leave with a parting story. I was part of the team that built, Google Plus, our social platform, and one of the users of the platform was a K-pop group from Korea called AKB48. From Japan actually, and which stands for Akibahara in Tokyo, and they actually do a member vote-in every year.
Oh no!
So our social team was actually not prepared. It had not developed the product to have a single user with so many comments that exceeded a few per second. So just to go back to your point, everything will be used and abused in the most unexpected ways by our users.
Yeah.
And that's how I learned about AKB48, which actually has 64 members, not 48.
Oh my gosh. It's kind of like Menudo. The vote in, vote out. Yeah. Oh, it's an excellent story. Thanks a lot for coming on, and thanks for everyone for listening. If you have any questions or comments, you can tweet us at pure_DT or send an email if you're into that at pureperformance@dynatrace.com. Acacio, do you have a Twitter handle?
Acacio Cruz.
Okay, Acacio. Yep, and that'll be people in the description, so definitely make sure you follow him. Thanks for listening, and Andy, great to have you back on after your move, and hope you're enjoying life back in Austria. You see any koalas?
Any what? Koalas? Yeah, exactly. That's the other Austria on the other side of the globe.
All right. Thank you, everybody.
Thank you.
Thank you.
Bye.